Today we'll be looking at signal spaces and how the Gram Schmidt Orthonormalization process can be used to create a signal space. What is a signal space? In order to conceptualize what a signal space is, think about signals as points in a space instead of their usual representation as functions. That is what a signal space allows us to do. We will talk more about this later. Let us consider how to create a signal space. In order to demonstrate this, let us consider an arbitrary set of 5 signals as represented here on the screen. We will then apply the Gram Schmidt Orthonormalization process to these signals in order to create a basis that is both orthogonal and normalized. Once we have completed the process, in this case we will be left with 3 functions that can be used as our basis. We will then represent our functions as axes in our signal space. Since each of our signals can be represented as a linear combination of the basis, we can use the coefficients to represent signals as points in the signal space. So what are some of the benefits of a signal space? First of all, a signal space allows us to do mathematical manipulations with vectors instead of functions, which oftentimes is a lot easier to compute. Another benefit is that the energy of a signal can be found by finding the magnitude of a vector instead of the magnitude of a function. So, in order to calculate the energy of a signal, by definition, you have to calculate the magnitude or the norm squared of that signal. Now, for a function, that requires taking an integral. But when you're calculating it in a signal space, it is represented as a point. This allows us to calculate the energy of a signal based off of the distance the signal appears from the origin, and is therefore much easier to calculate the magnitude. The reason we can calculate energy in our signal space is that in the Gram Schmidt process, we normalize our basis. This normalization process actually creates unit energy for our basis. Therefore, energy is conserved. One extremely useful orthonormal basis is a two-dimensional signal space spanned by the sine and the cosine functions. An important application for this signal space is that it can be used to send signals that convey information, most commonly binary code. When trying to send a message that is in binary code, signals are chosen in the signal space to represent different combinations of ones and zeros, such as 0, 1, 1, 0, 0, 0, and 1, 1. The coefficients are then multiplied by the sine and the cosine basis, which gives a signal that can be transmitted through some medium. This process is called modulation. The receiver, on the other end, can use the coefficients of the sine and the cosine signal waves to determine what the original message was. Thanks for watching, and we hope you enjoyed this video.